In this video, I'm going to be talking about scales of measurement, which has to do with different ways of assigning numbers to characteristics of objects or events. So if you remember from a previous video, when I defined what measurement is, I said one definition is that a measurement is a procedure for assigning numbers to characteristics of objects or events, which can be compared to other objects or events. So scales of measurement has to do with what kinds of comparisons are valid based on the nature of what we're measuring and the way we've assigned numbers to it. So I'm going to talk about 4 scales of measurement. If you're trying to remember this later on, kind of a little mnemonic you can think of as noir, N-O-I-R, like in Pinot Noir or film noir if you're into that, the French word for black. So the 4 terms are nominal, ordinal, interval, and ratio, N-O-I-R. And I'm going to get into what each of these 4 means next. Okay, nominal variables are variables where the numbers that we've assigned represent categories. These categories can have different names, but the different numbers don't represent any other kind of relationship besides what category something is from. So the valid comparisons we can make with nominal variables would be whether 2 things are equal or not equal, and that's all the comparison we can make. So an example of this might be if I do a survey where I ask people, what's your major? These are students. And some people say I'm a psychology major, some people say I'm a human phys major, I'm a journalism major, so forth and so on. In my database, I might record with a set of numbers. So I might assign a 1 to psychology, a 2 to human phys, a 3 to journalism. So now I've got these numbers assigned to different majors. I can make a valid comparison about whether 2 people have the same or different major by saying, do they have the same or different numbers? So are their numbers equal or not equal? That's a valid comparison. But none of the other usual meanings of numbers apply. I can't say that if psychology is a 1 and human phys is a 2, that one of those is greater than or less than or twice as much or any of that kind of stuff. It's just, are they the same number or different number? Some other examples would be your UOID. We all get assigned a number that's our ID number at the university. Those numbers, if they're the same, mean it's the same person. If they're different person, that's all they mean. A lot of times when researchers measure racial group identification, they might ask people which of these categories best applies to you, and in their data set they might assign those numbers, but the numbers don't mean anything besides same or different. Okay. The second scale of measurement that I'm going to talk about is ordinal measurement. With ordinal measurement, we've assigned numbers to objects or events, but now the numbers represent ranks. So by ranks, I mean things like first, second, third, or top, middle, bottom. With ordinal variables, we can make all of the same comparisons as we could with nominal. So those, when I say all of, it's really just to equal or not equal. But in addition, with ordinal variables, we can also compare greater than or less than. So for example, let's say I ask you, what was your class rank in high school? And you say I was first, and somebody else says I was second, and so forth. So I can say, well, your class rank was higher than their class rank. I can say greater than or less than, and that's a valid comparison. Let's say a bunch of people run a race and I measure whether they came in first, second, third. So again, I can say, well, this ranking was, greater than or less than that ranking. But nothing else about their finish time is captured in that way of assigning. So for example, let's say you have a race where the first place comes in 20 seconds sooner than second place. Second place only comes in 3 seconds sooner than third place. When I say first, second, third, it doesn't capture those differences. All it captures is what order they came in. So it doesn't contain that additional information. We don't know first is faster than second is faster than third, but we don't know by how much or how little. Likewise, if I were to ask you what are your top 10 favorite movies of all time, and you were to rank them, I wouldn't be able to tell is your number 1 like way above. That's the only movie I ever watch every weekend when I have time to sit down and watch Netflix. That's the only thing I ever watch. And all the others, you made me name 9 others, whatever, they're all the same. Versus somebody else might say, here's my top 10, but they're all super close together. I love them all. The ranking wouldn't tell us about that. It would only tell us what's higher or lower, what's greater than or less than. The third scale of measurement is interval variables. With interval variables, the numbers represent the distance between levels, or to be a little bit more specific, the distance between the numbers represent the distance between the levels. But 0 doesn't have any special meaning. So with interval variables, we can make all of the same comparisons that we could with nominal or ordinal, but we can also calculate meaningful differences between two numbers. So let's say, for example, that we're measuring temperature in degrees Celsius. And let's say that we measure the temperature today and tomorrow and the day after. And let's say that today it's 17 degrees Celsius outside, tomorrow it's 18 degrees, and the day after tomorrow is 20 degrees. So we can say from today to tomorrow it increased 1 degree, from tomorrow to the day after it increased 2 degrees. So we can say the increase from today to tomorrow was half as much as the increase from tomorrow to the day after. It was an increase of 1 versus an increase of 2. So we can make meaningful comparisons among the differences, but we wouldn't say just, oh, well, it went from 17 to 18, 18 to 20, that was like a different percentage change or anything like that, because 0 isn't necessarily meaningful with degrees Celsius. Another example would be, let's say that we're assessing the year that you were born, and we have different participants in an experiment. We've asked them what year you were born, and you tell me I was born, I'll just make it up, in the year 2000. And then, the next person after that says, I was born in the year 2005. And the next person after that says, I was born in the year 2006. So we can say the difference between you and that second person is 5 times the difference. It's a 5-year difference than the difference between that person and the next person. So we can say that's a meaningful difference. But we wouldn't say, oh, that person is 5 2000ths more years since they were born, whatever, blah, blah, blah. We would just say that the differences are meaningful, but 2005 isn't, whatever it is, 2.5% higher than 2000 or something like that. Something that psychologists debate about is whether rating scales can be treated as interval variables. So, and I mention this in particular because I want you to have some sense that, these things aren't always just obvious and universally agreed on. Sometimes they're things that are contested that we have to test hypotheses about, just like we do with everything else in measurement. And this is an example of that. So let's say I ask you, how satisfied are you with your life overall on a scale from 1 to 7? And let's say that you say, I'm a 7. My life is going fantastic. Everything's wonderful. I'm a 7. Let's say that I say I'm a 6. Let's say that my friend Eric says he's a 5. So the question is the difference between you and me the same as the difference between me and my friend Eric? Are you as much happier than I am as how much I am happier than my friend Eric? If it's an interval scale, we'd say, well, there's a difference of 1 between you and me. There's a difference of 1 between me and Eric. So those are the same amount of difference. The differences between you and me are the same as the difference between me and Eric. And so again, this is something that when we give these kind of rating scales, researchers debate sometimes whether they can be treated that way as interval, or should we just treat it as ordinal and say that you're happier than me, I'm happier than Eric, but we can't say something about the difference. But at least some researchers argue that we can treat those as interval. The fourth scale of measurement that I want to talk about is ratio variables. So ratio variables are kind of like interval, but now 0 is meaningful. And so we can make all of the same comparisons we could with interval. And remember, interval included ordinal, ordinal included nominal. So all the comparisons I've talked about until now, we can make with ratio. But in addition, we can use ratios to make comparisons. So let's say, for example, we're taking walks to get out of the house, get some exercise. And every day we track how much we walked. And let's say that yesterday I walked 2 miles and you walked 1 mile. So we can make this with nominal variables, we could compare equal or not equal. We can do that here. We can say we didn't walk the same amount. With ordinal variables, we can compare greater than or less than. We can do that here. I walked further than you walked. With interval variables, we can compare differences. We can say the difference between us is a difference of 1 mile. And if my friend Eric walked 3 miles, we can say that difference is 1 mile. That's valid. Those are the same difference. But in addition, now I can make a ratio comparison. If I walked 2 miles and you walked 1 mile, we can say I walked twice as far as you did. We can do multiplication. That's something we couldn't do with interval variables. And so ratio variables, the reason we can do that is because 0 is meaningful. 0 miles means 0 miles. Whereas if you think about like that interval scale, there wasn't even a 0 on the scale, wouldn't have made sense to make that kind of comparison. So a lot of physical measurements are ratio variables. Some examples are things like distance might be measured in meters, mass measured in grams, temperature. When temperature is measured in Kelvin, it's a ratio variable because 0 Kelvin is absolute zero. It means no movement among the molecules. So those are ratio variables. In psychology, one kind of ratio variable we might have would be counts of behaviors, and that's something we do a lot of times with observation methods. So let's say we have subjects in an experiment and they're doing some pleasant task, and we might be videotaping them, and every time they smile, we make a little mark in our notebook that says this person smiled, and so we can make a valid comparison. If you smiled 10 times and I smiled 5 times, we'd say you smiled twice as much as I did. That's a count of behaviors. 10 is 2 times 5. And we would say that that is a valid comparison to say you'd smiled double as much as I did. So just to recap, these scales of measurement, nominal, ordinal, interval, and ratio, are about when we assign numbers to characteristics of objects or events, what kinds of valid comparisons can we make based on how we've assigned those numbers. So if something's a nominal scale, like your major, we can say if you have the same number, if the numbers are equal, then it's the same major. If they're different numbers, not equal, then they're different majors, but that's it. If you look down the second column for ordinal, we can make that comparison too, but if it's something like what place did you come in the race, now we can also say, well, first place is a lower number, in this case with place in a race, lower means better. So we'd say it's first 1 is less than 2, a lower number is better, so you came in better, etc. That's a valid comparison. With an interval variable, that's that third column there, we can make all of those comparisons, plus we could say how big is the difference. And so if the change in temperature from today to tomorrow is 1 degree, but the change from tomorrow to the day after is 2 degrees, we can say that's twice as big of an increase in temperature from tomorrow to the day after as it was from today to tomorrow, so we can compare the differences between numbers. With ratio, we can say how many times bigger is it. So if I walked twice as far as you, we can say 2 times as far. If I weigh 2 times as much as you do, we can say I weigh 2 times as much as you, etc. And those are valid comparisons. Okay, that wraps it up for this video. Don't forget to do the concept check questions, and I'll see you in the next one.